Try to be efficient. It's the 27th. And today we will talk about the quadratic formula. Notice the capital letters. That is a proper noun, okay? It is not just some random formula. So just to get some language stuff out of the way, it is not the quadratic equation. It is the quadratic formula, which is used to solve common noun quadratic equations. So the quadratic formula is what it is. And this year I will teach you, not for a couple of weeks, where the quadratic formula actually comes from. I don't think that was something that we would want to do in Algebra 1, but it's interesting to see that it's naturally just, it exists, and it's really cool if you're into that kind of thing. So for today, though, before we can talk about the quadratic formula itself, let's do a quick review on simplifying radicals. So if you remember all this, you don't need to write it down, but one of the skills that we're going to need now to just have in our back pocket every day is how do you break down a radical. So remember, when we talk about simplifying a radical, that doesn't mean to approximate it. It doesn't mean to type it in a calculator and give me like 2.89. No one's interested in that. Do you guys remember how to break down a square root? Right. And so you can take the square root of 8 and you can write it. Some people make a tree like this, where they put two blank square root signs. Some people do it like this, where they just put the square roots right next to each other. And some people do it like this, where they just put two numbers inside of the same square root. I don't really care. Whichever one of those methods will probably just feel better to you. I don't care which one you pick. So if you're a tree person, then it would look like this. You would logically pick 4 and 2. Not only because they're the only numbers that make 8, but because 4 is conveniently square rootable. And what's the square root of 4? So my final simplified root is 2 root 2. That's just what we do. It's just a thing. And so if you did it the red way, it's the same as a tree. It just doesn't look like a tree. So you would put your 4 and your 2, and you would get your 2 root 2. If you like it the white way, then you can just put the 4 and the 2 inside of one root like that. And then just acknowledge that the square root of 4, that's a good guy, right? Square root of 4 is going to bust out of jail and become 2 root 2. So I mean, so you see we have the same thing. It's just a matter of, so as I go through this lesson, I don't necessarily know how I'm going to show my work, but just know that that's what we're doing as we're breaking those down. So let me give you a harder one. What's the square root of 32? You'll remember from Algebra 1 how we made that list of numbers. It was like a red list or something, I think we called it, and it had all the numbers that can be square rooted on it. You don't want to pick 4 and 8. What's the better combo for 32? Do you remember, Bryn? Yeah, so the square root of 32 is the square root of 16 and the square root of 2. And we want to go big or go home because, you're right there, Brady? Yeah. No, okay, good. We want to go big because we don't want to have to re-simplify something that isn't done. And the square root of 16 is 4, so this one would be 4 root 2. How about the square root of 75? What would that break into? It takes 3/4 to make 75 cents. So we would have a root 25 and a root 3, which becomes 5 root 3, right? And the numbers will get bigger too. What if we had like the square root of 192? For the record, some roots can't be simplified, but it's your job to do your part and check. And so these numbers, the bigger numbers, get a little rougher because now you got to go through that list of numbers, and the calculator is okay because it'll help you find what we want. So the numbers that we're identifying or that we're inspecting are 4, 9, 16, 25, 36, 49, 64, 81, ... You remember those. And so you press your way through that list of red numbers until you find what you're sure is the biggest one that can go into 192. Did you find it? What is it? There it is. And so if you take the square root of 192, you can break it into the square root of 64 times the square root of 3. And the square root of 64 is, of course, 8. So the simplified version of this is 8 times the square root of 3. Okay. Let's go again. How about the square root of 80? This isn't optional, okay? So this isn't like a learn it if you want to kind of thing. You'll get all your questions wrong if they have simplifiable roots and you don't simplify them. This was one, I wouldn't expect you to remember this from 5 months ago, but this is one that we talked a lot about as one of the evil numbers. It's hard because people always go to 4 times 20. 4 times 20, 4 times, it just comes right to mind because it's obvious and easy, but it helps to memorize certain kind of deathy numbers, like 80 is a bad one, 16 times 5, so the answer is 4 root 5. So bear in mind throughout today's lesson and tomorrow's work, and actually for the next, like, I don't know, like 7 months, that all radicals need to be simplified. Okay, it's not optional. Good. Okay, so having said that, let's talk about the quadratic formula. You know, there's a little song that goes with it. And the quadratic formula is what we do basically either if we're lazy or if we've encountered a quadratic equation that we cannot factor, right? And so, for example, well, here, I'll just make one up real quick. Say we had like x squared minus 4x plus 10. No, change that to a 2 because I don't want negatives. I don't want imaginary solutions. So this. So if this were our quadratic, one of you little turtle monkeys, did someone walk in and like theft my note card? Turkey, lurky. Either way, so you look at something like this and you say, like, I can't factor this, right? I mean, you would try. If this were on last night's homework, you would try, and you could try to build your shells, and it would take you not very long to realize that this is a fruitless endeavor, right? It's not going to happen for you. So this is where we go to the backup plan, the old quadratic formula. And the quadratic formula is there to give us, it's not something that we want you to use all the time. Pablo and I talked about this yesterday. If you can factor, I expect you to factor most of the time, but this is our backup plan. And so do you guys by chance remember the quadratic formula? You still remember it? Yeah. That's so cool. I'm glad. I'm ready. You don't have to sing it if you don't want. What do you have? That was impressive. Good job. Yeah. And, you know, the good thing about the quadratic formula is that it always works. There's something so nice about being able to look at something and say, you always work. And that's why some people are so attracted to it, is because it's just nice. It's just nice to know this will always work. Any equation that is a quadratic can be solved using this formula. It's just not always the most efficient course of action. So let's get to it. Step 1, you remember, is to set it equal to 0. And then step 2 is to figure out who are my A, my B, and my C. And so A, you'll recall, is the number that's attached to x squared. So A is 1. What's B? Good. And what is C? Good. I write those down, and not everybody does. I don't really know why. I guess if you're successful without writing them down, then great. But if you find yourself encountering any difficulties, you might want to think about explicitly stating who A, B, and C are. You might find that helpful. You mean the A, B, and C values? No, it's actually both. So there's 2 pathways, and I did find my note card as we go through these examples. I handpicked them so that we can have that conversation, but remember that there's a pathway that's a plus pathway, That gives us one answer, and there's another pathway that's the minus, and it gives us a totally separate answer. So we don't really figure out if it's one or the other, it's both. So let's go ahead and plug this into the formula and just let it happen. So we're going to say x equals, and here we go. We're off. What do we put first? 4. And then we put plus or minus, and then we draw a big long square root sign. Good. And you'll remember, if you've had me before, which all of you except 2 of you have, you'll remember that I'm a big fan of not writing in b squared there, but rather just doing b squared. Just do it. You know it's always going to be a positive number because whatever you're doing, it's squared. Just always put it in. Do it in your head, put it in. Now, I'm going to put -4, and then I'm going to leave a and c blank. I like to come back. And then I'm going to put it over 2 times 1, which is good, 2. There's something to be said for taking a pause and then going back and backfilling a and c. Just keeps us from doing stupid things. At least it does for me. So now I'm going to go back, and in those 2 awkward blank sets of parentheses, I'm going to put a, and I'm going to put c, right? This is, I'm sure, coming right back to you. Okay, maybe. So now I'm going to simplify inside of the square root next. This is called the discriminant, and we'll talk more about that in this class. But the discriminant is my priority. That's my focus. And so now I need to simplify. So I'm going to say x equals 4 plus or minus the square root of what? So I'm just going to put 8. Do you guys, by chance, remember when, I'm going to use blue, so watch for blue writing here for a second. Do you guys remember when that minus sign changes to a plus sign? Do you remember what would cause that to happen? If it encounters another negative. So the red numbers that I have up on the board, if one of them is a negative, and it's usually going to be this idiot here. C we don't have control over, so when C is negative, then the minus that I have circled in blue eventually comes across that other negative and says, hey, let's pair up and make a plus. And so about half the time when you're doing the formula, you'll wind up with addition. And so this is why I started class the way I did, is because this answer, it'll get marked wrong because it's just like an unreduced fraction. So what is the square root of 8? Good. So what we have now is 4 plus or minus 2 root 2 all over 2. And the last thing we always want to do is simplify the numbers in the little Bermuda triangle here. So this all should be coming back to you now. Those 3 numbers in that triangle can all be divided by 2. You don't want to go down this road unless everyone plays nice together. They can all be divided by 2, which is going to leave us with a final answer of x equals 2 plus or minus root 2, done. And I might ask a question if I were sitting in my own class, like, well, what happened to the 1 that would go there and there? Neither one of them serves any productive purpose. They're just junk. So we don't like junk. The only place I would ever willfully put a 1 is right here where this green arrows are pointing. If that number cancels out in the Bermuda Triangle division, you got to put a 1 there to hold that place alive. But any ones other than that, trash them. They're waste. Is that ringing some bells? Sparks, it's been a while. Is that looking familiar to you? Slightly. Okay, that's better than not at all. Let's go again. This is not the kind of lesson where I'm going to do 2 examples and say, you should know this, good luck. This one's a little rougher, so this will take time. That's, I think, why tomorrow's a work day. What's the first thing we have to do? Move the 5x, make it equal 0. You both said beautiful things. Same thing, different ways. So we want to take the 4x squared and leave it because it's positive. Remember, he determines the side on which we'll do our work. So 4x squared, stay. 5x, jump across and become minus. 84, just scoot aside, but stay minus. Good so far? What's A? What's B? Good. And what's C? Good job. That's that. Now you keep the quadratic formula for some of you in your brain, for some of you on a little section of your notes, but it ought to be just right there. If you haven't memorized it yet, you probably will just out of necessity over the next couple of days. So we begin. X equals. Careful, please. The quadratic formulas, negative b, so it's 5 plus or minus the square root of 25 minus 4 blank blank all over 8. Good. And then I go back, I pause. I don't usually pause this long if I'm doing it by myself, but I do pause. This is how I do them, like on an answer key. And then I go back and I change A and C into numbers. So A is a 4 and C is a dun, 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 watch out. It's a negative 84. What does that mean? It's going to change to plus, right? So the discriminant is actually going to get bigger. Sometimes we subtract, sometimes we add. It gets bigger in this case. It's going to be actually very big. So this one's going to be a little bit of a pain in the booty. But this is what calculators are good for, is helping us with some of this annoying, like heavy lifting stuff. So we're going to wind up with x equals 5 plus or minus the square root of, and I would use my calculator without an ounce of guilt in this case. So what I'm going to type into my calculator is 4 times 4, which is 16, and I'm going to multiply 16 by 84, and I'm going to get 1,344. But understand that what I'm doing, I'm going to write it up here in green right above my square root, is I'm actually doing 25 plus 1,344. Is everybody on board with that? That's really important. The minus and the negative encounter each other eventually. And so my square root is 1,369. And then I'm going to divide that by 8. Are we good to hear? So this is where you start chipping away at the stone. The first thing that you'd obviously want to check is, can I just outright square root 1,369? So that's where you have to have some familiarity with your own calculator and know how to do that. So I'm going to type in the square root of 1,369, and I'm like, jackpot. So like, I don't have to deal with the tree because I just figured out that the square root of 1,369 is 37. So I'm going to rewrite this now as 5 plus or minus 37 all over 8. Does anyone remember? Sorry to be annoying and ask this, but it's always curious for me to know, like, who remembers stuff. Does anyone remember how we proceed? Brady?
Once you add and subtract 5 to 37, then you get the answer right.
Right, good job. And you'll actually wind up doing them both, right? And so this is where these are, good job. These are called rational solutions. And so this means that the problem could have been factored. We're not doing it that way. So the answers that we're going to get, I'm going to use colors for this. I'm going to start with yellow, and I'm going to circle the plus sign, just so you remember. So we ignore the minus, and we just do some like fourth grade math here. What's 5 plus 37? So one of my answers is 42 over 8, which I will simplify to 21 over 4. That's going to be a solution. Then, like Brady said, I'm going to trace the other pathway. And the other pathway I'll circle in blue, and that's called a minus. And then you do the other math. Ignore the plus now. What's 5 minus 37? Negative 32. And then we again divide it by 8. And what's negative 32 divided by 8? Negative 4. So we want to present our solutions in a nice little kind of cohesive package. So we say x equals 21/4 and x equals negative 4. As I said before, with these quadratic formula endings, if you can go further, you're expected to. Okay. Let's go again. I tried to get a sampler platter of some different sorts of things They're never like really different at the beginning very much. It's just that ending, that last 30 seconds that's like critically different from one to the next. So let's do 2x squared minus 8x equals 13. What do we do first? Move the 13 over. So we get 2x squared minus 8x minus 13. What's A? B? C? Yep. Just something about seeing them, at least for me. So let's do it. It's time to begin. We're going to write x equals, and here we go. What's first? Quadratic formula is negative b. That's the second time in a row you guys have tried to pull a fast one and make it start with negative a, so watch out. It's opposite b, and then we go plus or minus the square root of. What's negative 8 squared? 64. If you haven't heard me say this, and I will say this again, apologies to those of you that hear it, I'll say it 10 more times. B squared will always be positive. If you ever catch yourself writing a negative number where I just wrote 64, go back, fix it. It's something squared. It's going to come out positive. So even if, not that you should because you're in high school, but if you typed negative 8 squared in your calculator, it's going to say negative 64. That just means you don't know how to use parentheses. So don't let the calculator overrule your common sense, right? You know anything squared is going to turn positive, so don't mess that up. And then I'm going to put minus 4 blank blank. I'm going to put it all over double A, which is 4. Take a quick pause and then come back. What's going in place of my blanks? Mm-hmm. So this will be a switcher, huh? This will wind up being an addition problem. And you got to remember that this, I'm going to put a little blue bubble around these. Those 3 numbers in the blue bubble, they need to be multiplied together first. And I don't want to have conversations with you about, is that a 4? Is that a negative 4? That's a dirty road to go down. Some people see it as a negative 4. Some people see it as a 4. I couldn't care less. The bottom line is we've already established that it's changing to plus. So at this point, I don't care about any more signs. I just care about 4 times 2 times 13. That's it. So I know it's going to be plus. What's 4 times 2? What's 8 times 13? 104. So what winds up happening inside of the square root sign is actually 64 plus 104, which is good. So we're currently sitting at 8 plus or minus the square root of 168, all divided by 4. 168 is not a square. It's really close to 169, which is, but it's not. So we got to do the tree thing. So off to the side someplace. Good, just get a little scratch space, get a little piece of notebook paper, whatever, and just get hammering on it. So this is where you diligently start going through that list of red numbers and going and going and going until you're sure you found the biggest square rootable number that there is. It's not going to take you long because it's not very big, for the record. Do you understand what I mean? You're typing into your calculator 168 divided by 4. And then you can try 168 divided by 9. And then you're going to try 168 divided until you just reach the logical conclusion that you found the best one. And I say it's not going to take you long. What is 168 divided by 4? And that should ring a bell to you. You should say to yourself, if I use 4, what happened to my poor 4? Holy, sorry, little buddy. Let's try again. Oh, there you go. If you use a 4 and a 42, you should know you're done. Because what's wrong with 42? Yeah, it's trash. You could break it into 2 and 21 or like 6 and 7, but none of that's going to do you any good. 42 is a dead number. And so you know when you pick 4 and 42 that you've maxed out what you can get. So we're going to break the square root of 168 down now into, we're going to say x is 8 plus or minus 2 root 42 all over 4. That was the root 4, root 42, of course. And then you draw, you don't have to draw it, but I mean, I draw it because I do this trying to get things to be visual for people. The triangle there, call it whatever you like. All numbers inside that triangle can be divided by 2. So our final answer is going to be x equals what?
4 plus or minus the square root of 42 over 2.
Perfecto. Still good? Did you say no?
Would you simplify it to be 2 plus or minus 2?
No, because in division problems like this, that's why I continue to draw this triangle year after year after year. Everyone has to play nice together. If you're absolutely hell-bent, which you shouldn't be, but if you're just hell-bent and say, I want to divide that 4 by that 2, then fairly you have to divide the root 42 by 2. And some people do it this way. Some math teachers actually do it this way. Some books might like you to do it this way. So if you wanted to go further, you could put x equals 2 plus or minus root 42 over 2. But again, the division of 2 has to be applied equitably to both parts of the term. So I don't see the point in pressing on beyond here. Does that make sense? Okay. Next one. This one ought to look a little clumsy. What's wrong with it? I always feel like if we could figure out why a problem makes us uncomfortable, let's fix it. It's missing its b. It's missing its middle term, as we call it. And so that's okay. We can remedy this by, this isn't, by the way, how we'll always solve an equation like this. We'll have different tools for this later on. But for now, since we're practicing the quadratic formula, we're going to write it as 6x squared plus 0x minus 5 equals 0. You can always put a 0 in. Always. What's A? B? C? Good. So there they are. It's time to apply the formula. So we're going to do x equals what? Good job. Nice job. So Alyssa, you did a really good job of just flat out disrespecting the b value, which quite frankly is what you should do. Once you acknowledge that the b value is 0, you notice there's a conspicuous absence of any number there and there. Where my blue arrows are pointing, you're used to seeing b's, and b squareds are negative b's, but if b is 0, they serve no purpose, right? Good job on that. You conquered that well. So we're going to now go in, and in place of our a and our c, we're going to put 6 and negative 5. And now the inside isn't an addition or a subtraction problem. It's just a clump of multiplication. What's 4 times 6?
24.
What's 24 times 5?
24.
Good. So we now have x equals the positive or negative square root of 120 over 12. I wanted to make sure this got into your notes because you're going to see instances where there's a missing b. And this is just what your answers will look like. Can you break down the square root of 120? And again, it's not very exciting, but there is progress to be made. What are the numbers that make 120? 4 and 30. Yeah, that's actually going to be the best we can do. 30 is the stupidest number because 30 feels like I could do so much, but all the 30's factors are stupid. 2 and 15, trash. 3 and 10, trash. 5 and 6, trash. So 30 is actually a dead number. So you would break this into the positive or negative of, so if you think of it as root 4, root 30, then you get 2 root 30 over 12. And this time, Sutton, we can do what you wanted to kind of do last time and attack it a little bit more aggressively because the triangle doesn't exist this time. There's a 0 out there that has no relevance. And so now I can just straight up like 4th grade reduce this fraction in the red box right here. What can 2 and 12 reduce to? Yeah, so we wind up with x equals the positive or negative of root 30 over 6. Not all problems are created equal. Okay, ready for the next one? Okay. 2x squared minus 40 equals 2x. What do we do first? Move the 2x over. So we get 2x squared minus 2x minus 40. Like this. What's A? B? C? I paused there just to see. When there's 15 people in a room, you just kind of, as a guy like me, you have to wait and see. Is anyone going to bring up the fact that all of these numbers could have been divided by 2? And you didn't say anything, so I figured I would wait and roll with it, but I wanted to point that out, that you can divide everything if they all play nice. So in a case like this, like if anyone wants to go rogue right now, if anyone's feeling like I got this, I'm bored, you could go and do the problem now with all of the numbers having been divided by 2. We as a class are going to do them like they are up there in red, but I'll write them in blue. What's 2 divided by 2? 1. What's negative 2 divided by 2? And what's negative 40 divided by 2? So an interesting experiment here, if neither of us messes up, if you do the blue numbers for A, B, and C, and we do the red numbers, we're going to come to the same place. Who's going to have an easier task? The blue. And so kind of a pro tip for you going forward is if you see division, it's not going to kill you if you miss it, but if you see it, you should take it. It's kind of nice. So let's press on with red, guys. So here we go. X equals what? We're going to do red numbers. Yeah, 2. I'm doing the red numbers because that's what I think you would have done on an assignment. So I want to do it the way you probably would have hit it. So 2 plus or minus the square root of what? 4 minus blank blank all over. Take a pause, short pause, go back and backfill your A and your C. In place of A, we'll put 2. In place of C, we'll put negative 40. Is this going to be an addition discriminant or a subtraction? This will be addition. And the math is pretty easy. 4 times 2 is 8. 8 times 40 is 320. So the number that we're going to wind up with is 324. If you had chosen the blue numbers, your square root, all your numbers would be smaller by a factor of 2, which is nice. So let's do this. I need your help with 324. It's not square rootable. I don't think. Oh, no. Maybe it is. What's 18 times 18? 324. So it is square rootable. So we can rewrite this as x equals 2 plus or minus 18. Nice. And Brady kind of reminded us of this earlier, that we proceed differently now with this. This isn't about the triangle. This is about just doing math. So we trace the plus pathway. What's 2 plus 18? 20. What's 20 divided by 4? So one of your answers is explicitly x equals 5. Done. What's 2 minus 18? Take the bottom road. What's negative 16 divided by 4? So your other answer is negative 4. And I don't know if you'll find this interesting. I'm gonna be done with my lesson. I had 2 more examples, but I just can't help but think that you've got it now. But I just wanted to show you one more thing. I find this to be massively interesting. I think when I first learned this, my mind was kind of blown. If we go back and we divide all the numbers by 2 right out of the gate, we would get this equation. Take a moment until you agree with that. And you look at it in hindsight and say, oh, I could have factored that. And that's where we make that connection, that these nice answers that don't have roots in them, 5s and 4s and stuff like that, they come from a very particular place. And that place is, oh, I could have factored this just like on last night's homework. Look at that. Quick and easy. And that's where 5 and negative 4 come from. You're going to get there. So you guys have any questions? I don't remember what purpose my others would have served, but you got to be good by now. Are you good? All right. So there's an assignment that Otto posted on Delta like 15 minutes ago. It's not due tomorrow, but we're going to work on it for 10 minutes or so, and then we'll work some more tomorrow, and I'll probably have some more for you tomorrow too. más práctica.